Hello. Today we'll talk about mainly this round robin scheduling algorithm, also known as RR. This is one of the most important CPU scheduling algorithm used in time sharing systems. As I stated, it is one of the simplest and widely used scheduling algorithm technique. Particularly, it can be seen with multitasking operating systems. Time quantum or time slice is one of the most important concept considered in round robin algorithm. Each process gets a fixed amount of CPU time. And what are the fixed amount of CPU time is considered here called as time quantum or time slice. If a process doesn't complete within its time slice, it is preempted and moved to the end of the queue. And we will see here that this is best example of data structure called queue. Let us see this example. We have 5 processes, P1, P2, P3, P4, P5 respectively, arrived at 0, 1, 2, 3, 4 as respective time units. The respective burst time for these processes is 5, 3, 8, 6, and 4. Now, let us assume that the time slice or time quantum is one time unit. Now, P1, which arrived at 0, so if we start at 0, P1 will start execution. After one time unit is done, it will see whether is there any other process in the queue, ready queue. So you see that P1 was working at 0, arrived at 0, completed one time unit. Now it identified that P2 arrived there because arrival time of P2 is 1. So now P2 would be given chance to execute. That's why P1 is preempted. P2 is given chance for one time unit. So P2 finishes its one time unit among the burst time for P2 to be 3. So it finishes one time unit. Now at 2, it sees that P3 arrived. So P1, P2 have to wait now. P2 is preempted, P3 is given chance. Similarly, P4 and P5 is given a chance. So one cycle is completed. Now, once a process completes the time slice or time quantum, it has to add itself into a queue. So that's why you will see now P1, P2, P3, P4, P5 would be added in a cycle again in the same order. Now you will see that they would be completing another time slice, one unit each time. So P1 finishes at one time unit at 6, P2 again one time unit at 7, P3 8, P4 9, and P5 10 respectively. So one time unit is done now in a second cycle. So for each process now, 2 time units are done. Now if we see again one cycle of P1, P2, P3, P4, P5 would be done. So this is third cycle that they completed at time unit 15. Now, if we see the burst time given for these processes, one can see that P2 had 3 burst time unit requirement. So it already finished it 1, 2, and 3 for P3. Okay, so now P3 is completed, it moves out of the queue. Now, after P5 at 15, instead of excluding process P2, the remaining process will continue in the same order P1, P3, P4, P5. So this is one cycle is done. Now we will identify here that P5, which had 4 time units, burst time to be 4 time units, it has completed at 19. So 1, 2, 3, and 4. So now P2 earlier preempted, P5 P5 is preempted. Now remaining are P1, P3, P4. They will again complete one time unit each. So at 22, they will be stopping. Now we will identify P1 already finished the remaining time quantum because it had 5. So P1 occurrence should be 5. 1, 2, 3, 4, and 5. Now P3 and P4 is remaining. So P3, P4 cycle would be done again for one time unit each. Now one can see P4 has completed 6 time units. So no process other than P3 is remaining. So P3 will complete with the remaining 2 time units in the consecutive order. Now we will consider this Gantt chart, which is drawn here as an example, to compute turnaround time and waiting time along with average waiting time and average turnaround time. Now, first of all, let us find out what is the completion time for each process. So if we see the same Gantt chart that we have drawn, because we'll require completion time to compute turnaround time. So P1, P2, P3, P4, P5. If you see the Gantt chart, at 20, P1 finished. So that's why completion time is 20. P2 finished at 12. That's why completion time is 12. P3 finished at 26. That's why completion time is 26. P4 finished at 24. So 24 completion time. And P5 finished at 19. So that's why 19. Now, if we subtract arrival time from the completion time, we will get turnaround time. So ultimately, we'll be getting the respective turnaround time to be 20, 11, 24, 21, and 15, which results to 91 as an sum perspective divided by number of process, that is 5. So the average turnaround time results to 18.2. Now here in round robin algorithm, computing waiting time is one of the most interesting factor to compute. Let us see this in the same example. So we already know now the turnaround time. If we see the diagram, P1 arrived at 0. Let us see like how much time it has to wait. Now, as this is a preemptive algorithm, after every time unit or time slice, process has to terminate or maybe preempt and then again add itself into queue. Correct? So P1 preempted. Again, second chance is given at 5. P1 when reaches to 6, again preempted, so on. So if we compute how much time between each cycle for P1, so once P1 finishes first cycle, till P1 gets next cycle, try to compute the in between time. So 1 for P1 we are computing 1, 2, 3, 4. Again P1 is given chance. So 5, 6, 7, 8. Again P1 is given chance. 9, 10, 11, 12, 13, 14, 15. Now P1 finishes at 20. That's why waiting time is 15. Now let us take example of P2. P2 arrived at 1 and finishing at 12. So let us take in between cycle 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. But while we are computing, we see that at 12, P2 already finished. So we should not go beyond 12. That's why we have to compute now the waiting time for P2 to be before 12 only. So 1, 2, 3, 4, 5, 6, 7, 8. And that is the reason why waiting time is 8. P3 arrived at 2, was given CPU at 2. So now again, each occurrence of P3 would be computing. Okay, in between process count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then 16. So P3 is having waiting time to be 16. Now P4. Again, P4 arrived at 3, given CPU at 3. So now after first occurrence of P4, between every occurrence, start to compute the number of processes or number of time units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Now after 15th time unit, P4 would be getting its last time slice. So that's why waiting time is 15. Now for P5, which arrived at 4, let us try to compute the waiting time for it. Now P5 arrived at 4, given CPU time at 4. Now each occurrence of P5 after first occurrence, count the number of time slices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this 11 would be waiting time per P5. So we got waiting time as 15, 8, 16, 15, and 11 respectively. If we take sum of this results to 65. So now if we divide by number of processes, we get the average waiting time as 13.0. So this is how we compute waiting time and average waiting time. You must have identified now what exactly we did while computing the waiting time. Now, as we are knowing arrival time, and arrival time was not having much distance or difference between each process arrival, this becomes easy. Now, you may try probably this kind of example where you try to take arrival time with more difference than one and try to compute the same thing. Then you will realize like how exactly it is different. Now, homework or practice purpose, what you can do is, here I have taken time slice as 1. You try to compute the same example with time slice to be 2, time slice to be 3, and so on. And then try to get the average waiting time and average turnaround time respective.